Okay, let us see how we handle this question here. It's a beautiful one. A force of this acts on a particle of mass 2 kg resting at a point whose position vector is this. Find the position vector of the particle after 4 seconds. So whenever they ask about the position vector, when we are dealing with these linear motions in a vector form, we think about the horizon. Our position vector on the solution is going to be RT equaling to the initial point, then after we get a displacement of that particle. So from here, start we need the point, our R points whose position vector is resting at the point. So meaning, from here we have our R as, let me give it in a vector form, 4, 3, negative 10. So that's all we have, but remember in our S, we need U, then plus a half a t squared. So we need acceleration, but you see, because it's from rest, our U is going to be 0 meters per second. Why? The body is resting. Then they are giving us mass. Our mass here is given as 2 kilograms, and they are giving us a certain force. They are giving us a force of 4, negative 12, then 16. Now, start with the acceleration. So, how can we get that acceleration from here? Anyway, you know that force, our force is equal to mass times acceleration. So, if we need acceleration, you can easily set our F is going to be force over the mass. So, can we get our F there? So, our acceleration is going to be our force, which is 4I minus 12K plus 16K the whole over 2, which is going to give us 2I minus 6J plus 80K. So, that's going to be our acceleration. As simple as that. So from here, because our U is 0, so our S is going to be a half a t squared. So meaning, now if we have the acceleration there, this is in meters per second squared. So our S is going to be a half a t squared. Anyway, so our T, anyway, we shall do it at once. So remember our T is 4 seconds. So putting it here, we have a half into our acceleration in the vector form, 2, negative 6, 8. Then our T is going to be 4 all squared. So our S now, here, is going to be a half of this. And this is going to be half of this you get 1, negative 3, then 4. We are multiplying it with 16, which would be 16 minus 48. Then this will be 64. So that is our S. So 16 minus 48, then 64. Then get our RT, which we said is R naught, then plus S. We are going to get our R naught was 4, 3, negative 10, then plus our S, which is 16, negative 48, then 64. So now, our R after 4 seconds is going to be, we add this plus this, we shall get our 20, this and this negative 45, then this and this 54. So now, find the position vector of the particle after 4 seconds. So, our position vector there is going to be 20I, sorry, this is I, 20I minus 45K, then plus 54K meters from the origin. So that's how it's going to be. If they ask for the distance, now we have got the modulus or the magnitude. So what about here? A particle starts from a position vector r. So you read as it summarized. So position vector r, which is 1, 7. With an initial velocity, so start. Remember they give you velocity in vector form, that is okay. But if they give you speed, you convert to velocity by multiplying the speed times the direction vector or the power vector. So our initial velocity there is going to be 4, 3. And acceleration uniformly, so acceleration is also being given as 1, 2 meters per second squared. Find the velocity after at any time t. So in simple terms, they're asking for the initial velocity is a plus ut. So this is going to be our a. This is u. Our u, which is 4, 3. Then plus my acceleration, which is 1, 2, then t. So at any time, our velocity is going to be 4 plus t. Then this is going to be 3 plus 2t meters per second. So that will be the velocity, which you can write as a vector form. The position vector at any time is going to be r naught, then plus s. So our r naught is going to be here 1, 7, then plus s. How do we get our s? Remember our s is given by ut plus a half at squared. So our initial velocity is 4, 3 times t, that's t. Then plus our half times our acceleration, which is 1, 2, then times t squared b. All people can complete from there. I think people can meet that answer there. You leave your t at any time t. That's why you are going to leave our t in there. So this is going to be 1 plus 4t plus 0.5 t squared. Then this is going to be 7 plus 3t, then plus t squared. Now this is our at any time, and leave it in meters. So if you don't give me time, it's okay. Put it like that. If they tell you now, yes, find after 1 second, you just where there is t, you put 1, 1, then you get the answer. See you there.